Hello and welcome to Study Circuit, doing GCSE Edexcel Astronomy, Topic 11, Exploring the Solar System. This topic will be in two parts. This is the part not containing telescopes. Let's start with some starter questions. Pause the video and have a go at them. And here are your answers. First, let's talk about objects in the solar system. So there are 5 different objects you have to know about. Planets, dwarf planets, asteroids, meteors, and comets. Now, planets are large bodies that orbit the sun. They are spherical, and the difference between planets and dwarf planets is planets have cleared the neighbourhood of their orbit, but dwarf planets haven't. Now, the difference between dwarf planets and asteroids is dwarf planets have a spherical shape, whereas asteroids don't. The difference between asteroids and comets are made of ice and dust, whereas asteroids are made of rock. And meteoroids and asteroids are different because meteoroids are tiny objects, whereas asteroids are massive. Let's talk about comets. So there are 4 parts of a comet you need to know about. The ion tail, which is also called the gas tail or the plasma tail, the dust tail, the nucleus, and the coma. So the nucleus is the part made of ice and in the centre of the comet. And the coma is a bit of gas around it created because it's moving. It's a bit like a shield. And the dust tail is just particles of dust from the comet created as it moves across the solar system. And the ion, gas, or plasma tail is caused by solar wind particles, which are charged. And this is the same effect as aurorae or the northern lights. And using a comet and the direction their tails go in, you can work out many things. So the direction the dust tail is in will tell us the direction the comet's moving, so we can see the comet's moving this way. And the direction the ion, gas, or plasma tail is in shows us the direction of the sun, so we can see the sun is this way. Now, there are 2 types of comets, short and long period comets. Short period comets will have a period, which is how long it takes a body to orbit the sun. And short period comets will have a period of under 200 years. And they will mostly rest in a place in the solar system called the Kuiper Belt, which is made of asteroids. This is the Kuiper Belt. It has quite a few dwarf planets in it. You can see Neptune is almost in it, and a lot of people consider it the outermost area of the solar system, consisting of many asteroids. And short period comets will reside in here as well. Long period comets will have a period of over 200 years, and their orbits will be a lot more eccentric than short period comets. Now, eccentricity is how squashed an orbit is. So if an orbit is really eccentric, then it's really squashed, it's really elliptical. Whereas if it's not very eccentric, it's more circular. Now we can see the orbit of a long period comet is very eccentric. Long period comets will reside in a theoretical area around the solar system. We don't actually know if this exists or not, but we call it the Oort cloud, and it's just a sphere of long period comets around the solar system. Now there's another area you have to know about called the heliosphere, which looks like this. It's cigar or bubble shaped, and it is caused by the solar wind of the sun, and it is shaped by the solar system's movement, its orbit around the galactic center. Here are some questions on comets and locations. Pause the video and have a go at them. And here are your answers. So the theory for the position of gas giants in the solar system is that because they are much further away from the sun than the terrestrial or rocky planets, they couldn't accrete the heavier elements that the rocky planets contain. However, they could accrete helium and hydrogen. Accrete means when lots of elements compact together to create a planet. And this is why gas giants are mostly made of hydrogen and helium. So water. There are two theories about how water could have emerged on Earth. The first theory is that Earth formed with water on it, and water just leaked through onto the Earth's surface. And the other theory is that it was delivered to Earth by comets, but a lot of people find that this theory may be half true. Some of it might have been delivered by comets, but it would have been hard for 71% of Earth's surface to be covered by water delivered by comets. So the ecliptic, which we talked about before, is the apparent path that the sun takes around the Earth. So here is the ecliptic, the purple line, and most planets, well, all planets, orbit around the ecliptic. Their line around the Earth that they take will be basically the ecliptic. And now you can see they have a small inclination from it, but we don't need to talk about that. When we talk about the ecliptic, we can talk about all the orbits of all planets, all the lines they take across in the sky. Meteors. So meteors are little bits of debris from comets or asteroids. They are absolutely tiny, and when the Earth passes through a group of meteors, it will cause a meteor shower. Now, I shouldn't be calling them meteors because in space they're called meteoroids, and you need to remember that. They're called meteoroids in space, meteors in Earth's atmosphere, and meteorites when they land on Earth. Okay, this is quite hard. There are 3 different units we use when we're talking big distances. Light years, which is the distance light travels in a year. Parsecs, which we talk about when we get onto heliocentric parallax. You don't need to know what a light year is yet, but you do need to know that it exists, and it is used more by professional astronomers. Light year is used by more amateur astronomers. And the astronomical unit, which is the distance between Earth and the Sun. So you'll be given these measurements, but you need to know how to convert between them. And in case you don't know how to convert between units, if you're converting from a larger unit, let's say parsec, to a smaller unit, like light year, you just multiply. But you see, parsec is given in light years, so you're going to have to convert lots of things first. So this guy called Halley, he managed to find a distance between the Earth and the Sun, the astronomical unit. And he did this using the transits of Venus over the Earth. So a transit is when a body moves past another body. And he got observers of different latitudes so one latitude here and one latitude here, to observe the different paths on the Sun Venus took when observed from different latitudes. And you don't need to know the crazy method involved in maths, but he had a really precise method, and he could use this to work out the distance between the Sun and Earth. Here are some questions about the things we have just covered. Pause the video and have a go at them. And here are your answers. Let's talk about probes. So, a space probe is made by humans, and it gets into space by reaching Earth's escape velocity to bypass Earth's gravity. And this is the same with rockets, which we saw in the Exploring the Moon topic. So there are 4 different types of probes. This is the first. It is a flyby, and this is a type of probe where it just flies past the bodies it's looking at. Now, flybys, a common thing it might do is use a gravitational slingshot, where it goes near a planet or body and uses its gravity to move faster to get to another. Now, here are some advantages of flybys, and here are some disadvantages. You do need to know these, but a lot of it is just common sense. Now, orbiters will orbit a planet many times, or a body, and this can give them lots of data. Orbiters are very good for a precise planet or body. Here are some advantages and disadvantages of them. Impactors. This is the tricky one. An impactor probe will collide with the surface of the body, disrupting materials on the surface, and a second probe will catch the footage and send it back. Here are some advantages of impactors, and here are some disadvantages. And the last probe is the lander, which is the most straightforward one. A lander probe will be put on the surface, and it can only work on the surface, but it can investigate composition and do experiments and things like that. So this is the tricky part. You have to know one example of a mission for each probe, the target body, and what the purpose of that mission was. So for the flyby, there was New Horizons, which mapped Pluto and Charon's surfaces. For the impactor, there was Deep Impact, which went to Tempel 1, which is a comet, and it investigated its internal composition. For the lander, there is Philae. I'm not sure how that's pronounced, but it investigated water-rich chemicals on comet 67P. And Juno, which was an orbiter, did many measurements on Jupiter, including gravity, solar wind measurements, and composition. Manned missions. So, manned missions are just missions with humans in, and unmanned missions are missions without humans in. And there are advantages and disadvantages to manned missions. And here they are. Now, the Apollo program was a program to land men on the moon. And this was successful, especially Apollo 11, which is the most famous one, where they managed to actually land men on the moon. And they left some things on the moon, including laser retroreflectors, which could measure the distance between the moon and Earth with a laser. They left seismometers to measure moonquakes, and they left solar wind detectors to measure solar wind on the moon. Here are some questions about missions. Pause the video and have a go at them. And here are your answers. Here are some final questions. Pause the video and have a go at them. And here are your answers. Thank you for watching Study Circuit Revision. Please make sure to like and subscribe, and my video on telescopes should be out very soon.